The sound of a car starting is like music to the ears when it's -15 outside. Today's batteries are increasingly powerful and efficient, even at the most extreme temperatures. Kinda heartwarming, isn't it? While dissecting a frog in 1786, the Italian researcher, Galvani, noted that when his scalpel touched a leg muscle, it contracted from an electric current produced. Later, Volta believed the current was produced by the metal instruments, the animal being only a conductor. To prove it, he stacked discs of zinc and copper, connected by conductors, and fabric impregnated with an acid solution. And so, in 1800, the electric battery was born. Batteries power all kinds of electric motors. A new lithium metal polymer battery pack, such as this one, could soon power an electric automobile, as well as a hybrid vehicle. This battery will be made up of 4 components. It all starts with this lithium ingot, which weighs about 5 kilos. It's transformed into a thin sheet by this extrusion press that applies 400 tons of pressure. From it will exit a sheet that's only about 250 microns thick. The whole extrusion sequence is closely computer controlled. Extrusion is now completed. The metallic lithium sheet is the required 250 microns in thickness, or 1/4 of a millimeter. The sheet has to be further thinned. Placed on a roller, it is carried to the laminator. At room temperature, it's thinned once again. In just 20 minutes, the 5-kilo ingot will have been transformed into a thin, 250 micron sheet, some 200 meters in length. This laminator completes the thinning of the sheet to between 20 and 40 microns. The resulting 2-kilometer-long sheet will allow for the fabrication of 210 battery units. Lithium is a soft, sticky metal. For this reason, a polypropylene film has to be fixed on the lithium sheet. Without this protection, the sheet would adhere to itself and become unusable. The sheet will be used to make individual battery cells. Then these cells will be assembled in series and in parallel and inserted into modules of different shapes. To make an individual battery cell, the sheet has to be rolled up. This automated spooling machine winds up the lithium film in 26 revolutions. The wound-up sheet is put into a vacuum oven where the various layers adhere firmly to one another. This step lasts for about 90 minutes at 80 degrees centigrade. Here, a test is made. Using a voltmeter, the battery is checked to see that it produces the required 3.56 volts. Any problem can be detected here and corrected. A final quality check is made with this caliper, which precisely measures the thickness of the battery cell. The battery cells are then stored. Metallic plates are placed between them for the entire storage period. One more step remains, and that's the metallizing of the contacts. The battery cells are sent off to a fabrication facility in this container. The container is robotically handled. First, it's put into a protective tank. Then the metallizing of the contacts is done by spraying on molten metal. This takes just a few seconds, since the metal cools very quickly. The battery is now finished. It comprises 4 elements: lithium, which acts as the anode, a metallic oxide cathode, a dry solid polymer electrolyte, and a metallic current collector. All that remains to be done is the assembling of the individual battery cells into a module. It begins with the placing of individual cells onto one another and isolating them with foam so that they don't touch each other. These red sheets are actually heating elements since the lithium metal polymer cells function at temperatures of between 40 and 80 degrees centigrade. All of the individual battery cells of the completed module are connected to an electronic card located above the module. The finished modules are connected to one another in series and in parallel to form a battery pack, which can be used in an electric automobile or a hybrid vehicle. Here we see these modules of a battery pack for a hybrid vehicle, an automobile that works with a gasoline-powered motor and an electric motor. This prototype battery was created for a totally electric vehicle. It surpasses heavy traditional lead-acid batteries that can't develop the same amount of electrical energy and which have much shorter lifespans.
Produces an electric current when its positive end, called the cathode, and its negative end, called the anode, connect via a conductive pathway in the battery-operated device. This pathway conducts electricity when three components, two electrodes and an electrolyte, interact. These alkaline batteries are the rechargeable type. They last for years, depending on how you use them. The factory begins production by cutting nickel-plated steel into oval pieces, then gradually shaping each piece into a tube called a console. The console houses some important chemical ingredients: graphite, which conducts electricity; silver catalyst, which reduces chemical pressure buildup; manganese dioxide, the main ingredient in the cathode; barium sulfate, which binds the cathode ingredients; zinc, the main ingredient in the anode; a gelling agent to keep the zinc particles suspended; and finally, potassium hydroxide, which interacts with electrodes to produce electricity. This 25-head press shapes the cathode's powdered chemicals into hollow pellets. The press churns out 25,000 pellets an hour. A machine called the console press then inserts 3 pellets in each console. 3 because these pellets are so fragile that 3 smaller ones are easier to manipulate than 1 big pellet would be. Here's the insertion in slow motion. The next machine makes a ridge on one end of the console to help seal it. Plastic holders, called pucks, hold the consoles still as nozzles apply a sealant to the top, which is the negative end of the console. Next, they cut a roll of paper into small strips. These strips are called separators. They have microscopic holes that permit the flow of ions, electrically charged molecules, between the cathode and the anode. A hot melt glue machine deposits a small amount of glue into the separator, now rolled, and seals the positive end of the paper tube. The glue cools and hardens over the next minute and a half as the consoles move along a conveyor. The next machine injects an electrolyte, a potassium hydroxide solution. It takes 9 minutes to soak through the separator liner into the cathode pellets. Nozzles then inject about 4 grams of zinc gel into the anode cavity. Only about 2/3 of the gel weight is actually zinc. The other third is this company's closely guarded trade secret. It's what makes these batteries rechargeable. The zinc gives the gel its silver gray color. A welding machine fuses 4-centimeter nails onto the cap of the battery. This is where current collects before it's discharged. The machine ejects the cap when finished, and another machine inserts it into the negative end of the battery. This cap includes a safety feature crucial to rechargeable batteries. It can resist high pressure, but if heat or power surges cause excessive pressure, a tiny vent prevents the battery from exploding. The machine folds over the console lip to enclose the contents. A rotating 3-headed crimping machine then makes a ridge in the finished battery to reduce the chance of leakage. An electrical testing machine contacts each battery for 200 milliseconds to ensure it has at least 1.5 volts. These batteries will be ready to use right away. No need to charge them first. The labeling machine uses light sensors to time the labeling of each battery casing. The plastic label lists technical information and adds additional insulation. Then, 3 seconds in an oven at 198 degrees Celsius shrinks the labels to a tight fit.